turning back. Nikusana tu mbele. Anyway, let me pass. Okay, welcome to my class. This is just going to be a quick walkthrough of data classification in less than 5 minutes about how some fundamental concepts when you're handling a classification problem in machine learning. And I'm going to use IRIS Dataset to illustrate some of these concepts. And basically the objective of this class is going to understand classification, where I'll walk you through samples, labels, features, what they are, and why is it significant. The Workbench is basically Jupyter Notebook, where we look at importing the data set, separating target and data into separate variables, and I also show you the code for splitting the data into training and data set and testing, and why that is important. And then we'll also look at modeling, understand what an algorithm is, how picking one from several algorithms that are available through a library within Jupyter, creating a model, what does that mean, and training a model, what that does mean. And eventually, we're going to do predictions, how we make the predictions, and then we'll look at the classification reports. Samples, labels, and features. A sample is just basically a random representation of a population. A population, IRIS dataset is a dataset for flowers. So we have 3 types of flowers, and these classes are what are called category. And the names of these classes are synonymous to the labels in the dataset. So we'll look at, for instance, the name Setosa. Setosa is the name of a type of flower. So IRIS is a huge population. So when you're talking about, you're just picking a certain number, like let me say 200 out of the available IRIS flowers, then that number that you've picked is sample. So it is randomized. You can decide that you use a certain technique, statistical technique to pick whichever samples you want to do in your studies. Now the label, like as I explained before, it is now the name. For instance, Setosa is the name. So that becomes the label, and it's the actual output that will be predicted. So you'll give your machine learning algorithm or model a set of features, and then the machine learning algorithm would be able to predict whether it's Setosa or not, or any other one of the 3 classes that the data set has. Now the features are the unique characteristics that actually define the Setosa. So it could be a petal width. The flower has a petal width. It could be the length, the petal length. So these are what characterize, or rather distinguish, one type of flower from the other. So these are called features in machine learning. And a certain combination of features enables the algorithm to be able to make the prediction of whether or not it is any one of their variable classes. So the Workbench in Jupyter Notebook, first of all, you need to import. So there is an sklearn library available to or in from within Jupyter that has this data set. So the code I'm projecting is the fastest way to get access to this IRIS dataset. Once you have it, you can separate the data and targets using the code that I've shown you on number 2. And then finally, number 3, we split into train test. And ideally, the train test is split into the features and the target. Both of them needs to be split into train test, where X train and X test, these are the features for both the train and the test respectively. And then Y train and Y test, these are the target variable for both the train and the test. So basically, why do we have train? Train is to enable you, this is the data that you're exposing to the algorithm for it to be able to learn the uniqueness of the various classes, such that when you expose now your test data to the algorithm, because it had learned using the train test, it will be able to say, okay, now this feature and this combination, it is most likely a setosa, or it's most likely a this with a certain prediction accuracy. Now, algorithm is basically a combination of statistical techniques that have been wrapped up together and made available to machine learning engineers through libraries in sklearn. So that is an algorithm. There are several algorithms. The one you're going to use today is called logistic regression algorithm. And this is how you import them. And instantiating an algorithm is as per line 11 that I'm showing you in the screen. So you create an algorithm by instantiating it, and then you train that algorithm. Remember, we had X train and Y train. You pick that data and fit it into the algorithm. By fitting it, that is the time now we are training it. Once you train it, there's so many parameters that are available, as you can see. And after training it, you are able to do the predictions. And after predicting, you are actually able to get some reports. And the reports we are going to look at today is classification report. So this classification report has certain metrics that help you determine the performance of your algorithm. And it also guides you to be able to see what else can you do to either improve the performance of your algorithm. Some of these metrics are precision, recall, F1 score, and support is basically out of the data that was given to the algorithm, how were the samples picked? 0, 1, 2 are now the various classes. So for 0, it picked 24 samples. For 1, it picked 22 samples. And for 2, it picked 29 samples. So the accuracy is between 92 and 93% on average. And that is now pretty much a good accuracy level. If you want to take it up, of course, there are several other things you can factor in. And this is just a basic classification machine learning problem in 5 minutes. Hope this gives you an idea of what it involves solving a classification problem, but let it not cheat you. There is so much more than this, especially with regards to visualization, analysis, hypothesis testing, depending on the problem you solve. So I hope you enjoyed this, and I look forward to your class. Cheers.